Hi, Chris Kuzmal here. We continue to implement our queue tests and our queue because our tests are driving the development of the queue itself. We've already implemented and successfully run test almost too much NQ and test too much NQ, which means the NQ method seems to be working, but the DQ method, we haven't even defined it, incorrectly or not. So let's go ahead and test dequeue when empty. This is a method that is analogous to the test pop when empty method, which we have copied over from our stack class. And so we slide our comments down so that the test pop when empty method is now exposed. This is, of course, not what we want. We want test dequeue when empty, and our object that we're going to use to test, of course, is going to be a queue uh, of type dishes, excuse me, of name dishes. And we're going to do the exact same thing as rather than popping. So we create a queue. It's empty. We check for we establish a variable had exception to be false, and we dequeue. We try dequeuing dishes. Oops, I'm sorry. Dishes.dequeue. dequeue. Now, of course, dequeue isn't even defined, so we get a compiler error. We don't even get to run yet. Let's scan through. It doesn't look like there's anything else other than failed test. The error message, failed test dequeue. When it be expected an exception, but did not get one. Yeah, so we'll be dealing with that as soon as we define dequeue at all. So let's define dequeue as a stub. So here we are back in queue. We've got NQ defined here. Let's do a definition, public void. Does dequeue actually it returns an int? Public int dequeuee. And I'm not thrilled with the name, this variable name being capitalized. So we're gonna the method being capitalized. We'll need to change that later on. So dequeue, which takes no arguments, it will throw a runtime exception, which is going to be that error that we get when we underflow on dequeue. And when is that? When we try to dequeue when the queue is empty. And when is that? It's if the length is less than or equal to 0. That's exactly when we want to throw a runtime exception. So we'll copy this runtime exception that we've already have down here in NQ, and it'll be queue underflow. And otherwise, we're going to return 0, which is incorrect. So this this should fail other tests that we create, but we're hoping that we'll pass the test for failing when we dequeue with an empty queue. So let's run, let's see what happens. It passed 3 tests. So that went so smoothly, it's hard to even believe. But this dequeue throws this exception of queue underflow. And so let's see what happens when we invoke it in our test again. This is test dequeue when empty, and we tried the dequeue, and what this test code does is it catches the runtime exception, and it increments passes and says had exception equals to true. And if it didn't have an exception, it prints the warning. And so yeah, it passed the test because it did get the correct exception. And as always, would like to make sure we experience both sides of that. So let's say less than or equal to 1 for our length. So now it shouldn't throw an exception. Actually, my mistake. Less than or equal to -1. So it shouldn't throw an exception when the length is 0. And that means that it failed the test, and we caught the test without the system crashing. So that's exactly what we like. But we of course, we don't want to leave this -1 here. We want this to go back to 0 and run our test one more time. And that particular test case works, and dequeue works for that particular test case.